In this section, we'll do a quick refresher on inequalities, just to remind you guys how to solve them. Well, first of all, let's take a look at the sum notation in which we'd like to have answers in. One is set notation, which is denoted by these sort of squiggly brackets, I would say. And set is really a collection of numbers. It looks something like this. X such that x is less than 1. Basically what this means is any x, as long as it's less than 1, would be in the set. Now there is no order in the set in the way it is in the interval notation. So really when we do the solutions to the equations, they can be in any order. So as long as it's and for the inequalities, we have to write them in this way because there are infinitely many numbers that would satisfy the inequality. So now let's take a look at the interval notation. Interval notation is a more visual way to represent the inequality because it's really tied directly to the number line. For example, x is less than 1 that we saw earlier can be represented because it's less than. Notice sometimes I think of this as like a little arrow. It's going to the left on the number line. And so it's written like this from negative infinity to 1. Note we use parentheses not to include the 1 as part of the solution because of the strict inequality. Now what if we have x greater than or equal to negative 5? Well, first of all, now the inequality changes direction, and then it's also the equals is included. So notice how we start at negative 5, but we're going to the right up to positive infinity. We include the bracket with negative 5, but with infinity we typically only include them in parentheses because infinity is not really a number. You can never actually achieve infinity and have it. And that's what it looks like on the number line. Exactly like the interval. Notice even with a bracket facing to the right. Notice how it's darker going to the right and so on. So remember, with number line we always go from smaller to greater. It's just to keep in mind. Now to the inequalities, let's take a look at the simple one. 3x minus 7 is greater than 2. Note how we typically solve inequalities pretty much same as equations, only one time it doesn't work, and we'll get to that. So first we add 7. Now adding a number, and you can check that with numbers, does not switch an inequality. So we can add 7 to both sides, and we will get 3x is greater than 9. And notice how we can divide by 3. Now dividing or multiplying by positive doesn't switch it either. You can check with numbers. So we'll keep it the same way, and we get x is greater than 3. And note how we write the answer as the interval as from 3 to infinity. You can draw it on the number line if you'd like. Again, it's going to the right. Or as a set notation, x such that x is greater than 3 in the set brackets. So that's to solve a simple inequality. Let's do a more complicated one. 1 minus 2x is less than or equal to 3. So again, we're trying to isolate the variable. Subtract 1. Subtracting a number again does not change an inequality, adding or subtracting. And so now note we're getting negative 2x is less than or equal to 2. But then we want to get rid of the negative 2. We want to divide by negative 2 on both sides. Now note, multiplying or dividing with inequalities by a negative number changes the order, because notice typically if you multiply or divide by negative, you do change sign, so it does change order of the number line. You can check it with quick number examples. So here we do get switched inequality. Notice how it becomes x is greater than or equal to negative 1. And so the answer would be, again, it's greater than, so it starts at negative 1 and goes to infinity, or it's x is such that x is greater than or equal to negative 1. So just a quick refresher. Then we can have more compound inequalities like 4 minus 3 in parentheses 1 minus x is less than or equal to 3. Here we need to do a little bit more algebra. We can distribute the negative 3, so we'll get 4 minus 3 plus 3x is less than or equal to 3. We can combine 4 and 3. They're like terms. Becomes 1 plus 3x is less than or equal to 3. We subtract 1. We get 3x is less than or equal to 2. We can divide by 3. Note, sometimes we do get fractions. We cannot always simplify it evenly. So in this case, again, there was no switch of inequality. x is less than or equal to 2/3. And because it's less than or equal to, note how we the answer should have been, let's see, I don't think that's included in here. We can actually write it. It should have been negative infinity 2/3, and we include it with a bracket. Okay, or we can write it as a set. Now note, what if we have answer 1/2 times x minus 4 is greater than x plus 8, and in this case we can multiply the inequality by 2 to get rid of the fraction. Notice how we can cancel the 2 in this case, and because we'll multiply by 1/2, we don't need to distribute it. So we actually obtain x minus 4 is greater than, now on the other side we multiply 2 by the whole quantity, x plus 8, we distribute it, 2x plus 16, and then we proceed as with the algebra. So just to recall, with fractions, if you have a fraction up front, well, you can distribute it if you like, but I prefer to get rid of them, multiply by common denominator, which in this case was 2. On the left hand side it got cancelled. On the right hand side, because there was no fraction, we just had x plus 8, we distribute it. And then we proceed. I decided to subtract the 2x first, put them all on the same side, so we get, notice how we get negative x, but it's greater than, also added 4 to both sides. Notice how we get 20. So negative x is greater than 20. And we divide by negative 1. So notice, if you recall, when dividing by negative, what happens? Jumped a little too much. We switch the inequality. It's less than negative 20. So again, we start at negative infinity up to negative 20 with parentheses. So this was one option, putting x on the left. If you put x on the right, you'd probably get the same answer, but you would get something like this, negative 20, but then you would get it as greater than x. And notice how it's written backwards, so you really have to rewrite it as x less than negative 20. Otherwise that would sort of screw up your answer. So it has to be in this order, where x is to the left because of the order of the number line. What are the solutions to the x? Next, let's talk about compound inequalities. Compound inequalities for us would be the two-sided inequalities. For example, like 0 less than or equal to x less than or equal to 2. The way I look at these is x is really between 0 and 2. And notice how we can draw it. It does not go to infinity in this case because really x is between 0 and 2. We do include them with brackets because of the less than or equal to. Or you can write it as an interval. Looks the same kind of idea. Or x is between 1 and 5, but it can be equal to 5. So notice we can write it very similarly with the interval. To solve them, we really would do it the same way as with equations, but we want to, for example, when we add 6, you want to do it to all three sides, on each side of the inequality. So in this case, we got 6 less than or equal to 2x less than or equal to 10. Same idea, you want to divide by 2, and so we get 3 is less than or equal to x is less than 5. And this is our interval. You can draw it on the number line if you wish. So similar idea. Occasionally you get an inequality with a negative in there. Like for example, the next one. Notice how in this case we subtract the 4 on three sides. Same idea. We're trying to isolate the variable. So we got negative 9 less than or equal to negative 3x less than or equal to negative 2. So the key is to remember to do it on all three sides. We can divide by negative 3, but notice that's always a little worrisome. Well, keep in mind we're dividing by negative. What happens with the order? The inequality switches with the order. So how does it look like? And it should make sense really, because the bigger one, so -9 divided by -3, we get +3, less than, greater than or equal to x, greater than or equal to 2/3. Notice how 2/3 is smaller than 3. So inequality should make sense. You should not have 3 less than or equal to x less than or equal to 2/3. That would not make sense. So just pay attention to the order. So again, we get something like this. Notice how I rewrote it because it was written backwards, and we can write the, our interval 2/3 with a bracket, comma 3 also with a bracket. They both had brackets associated with them because of the strict, actually with the equal signs, with the inequality. Then if we have fraction, if the whole inequality is over a fraction, again, we can try to get rid of it because there's really not much else you can do but get rid of the 4 in denominator. So this is what I did, multiply by 4 on all 3 sides. So we get -12. Again, we multiplied by positive, so it's still less than 2x minus 1. We cleared the 4. Less than 0 times 4 is still 0. Then we solve as usual, add 1 to both sides. So I'm getting, let's pay attention to signs. -12 plus 1 is -11. Less than 2x, less than 0 plus 1 is 1. And then we divide by 2. Notice we do get fractions, but that's okay. -11 over 2 less than x less than 1/2. And so that's the, oops, sorry, the last, and here we get the interval notation with parentheses because of the strict inequalities. And the last example would have, there is still a fraction here, but before we try to get rid of it, we can multiply, for example, by 2. But notice, because it's not the whole thing over 2, then you do have to distribute, and that would actually add a step, because if first you would distribute, then you would subtract the 2 or whatever number results, and so it results in more steps. Still would be right, but notice how first I subtracted the 1 just to get rid of it on all 3 sides. So what do we get? I'm getting 1 minus 1 is 0, less than -1/2 x, that's all that remains, less than 3. Now we can multiply by -2 to get rid of the fraction, which is what I have done. -2 times 0 less than -2 times the -1/2 x less than 3 times -2. Again, notice the order switches. So we switch the inequality. So it's 0 greater than x greater than -6. Again, it's written backwards, so we can switch it up. And it's really -6 less than x less than 0. And we get as the interval as -6, 0. And that's it.